Let's start with number 23 here. So I do want to have a variety of multiplying fractions and multiplying whole numbers. Thankfully, we really go about it the same way, right? But I just want to make sure that we are capable of doing both, okay? So when I look at this, I'm originally very confused because I have this 6, which is just like a single digit, and then I'm multiplying it by a fraction. Who can explain to me how we would go about doing this? And there are a couple different ways. Could anyone tell me the way that they would solve it? Justin, how would you solve this one?
So what I would do is I would do 2 times 6.
Oh, okay.
Or 6
So
times 2.
perfect. So I'm going to set this up. You're telling me multiply across the top like this?
Yep.
All right. What about my denominators on the bottom? What do I do then?
That's the part I usually get stuck on.
That's fine. So I'm going to help you here. So what we were saying, yes, I think it was yesterday or the day before, was that anytime it's a whole, you can just put it over 1. That means 6 wholes or 6 groups of 1, right? So what you can do is you can set it up the exact same way we had it and just put it over a 1. And that way, Justin, how you multiply the top, now you can multiply the bottom. And it's just going to be 1 times whatever the other denominator is. So anytime, so like 26 where it's 12, you could put 12 over 1. 28 where you're using a 5, it's 5 over 1. Anything over a 1 just means wholes, like 6 wholes, 12 wholes, whatever it is, or 12 ones. Now, Justin, could you, because we've been talking about this idea of simplifying, could you?
I already know what you're going to say. Yes.
Yes, okay. And how would I do it?
Well, 3 goes into 12 4 times.
Yes, yes, yes. Good. So you know that 12 divided by 3 or 3 times something equals 12, which is a 4. Beautiful. And that's what, if you're thinking about this, and the other way that we did it, and remember you guys, when we started this, we started with addition. We said addition's really good until it gets too big, right? But if you need in your brain to kind of think about this as 2/3 plus 2/3 plus 2/3 plus 2/3 6 times, again, it's getting a little bit big. That's the same as what Justin just did with multiplication. And you'd end up with 12/3. So 12/3, you could leave it as 12/3. It's not incorrect, but 4 wholes is just a much better way to do it. So let me do this. Let's go ahead and let's do number 28 together. I'll leave this here. You guys can look at that one while you do 28. I want you to try it really quick on your own and let's talk about it, okay? So I'll give you a minute or two just to kind of.
I can't see number 28.
Oh, yeah. Sometimes, okay, hold on. Sometimes my screen doesn't match your screen. Sorry. Can you see it now? Yeah.
Yes.
I forgot that my screen's a little bigger than yours, so you guys can't quite see everything. 1/5 times 5. I'll give you a minute or two to work through it. And please don't shout out when you're done. Just give everyone a quick second.
I maybe got the answer.
Okay. Just 1 second.
I got the answer.
All right.
I already had the answer for a while.
Okay, you can just say I have the answer. Bella L, would you be willing to share with us in just a minute?
Yeah.
Okay, so let's give everyone just one more second, and then Bella, I want you to work through it with us. All right, Bella, can you explain to us what you would do here?
What I did was I put the 1 under the 5.
Excellent. And can you explain why did we do that?
Because you put the 1 under the 5 because so you can times the bottom and the top.
Yeah, and it makes it 5 holes, right? Good job, Bella. Okay, what'd you do now?
And then I times 1/5 and
Mhm.
5 times 1.
Yeah.
And then I got 5/5.
5/5. Bella, what could I do to this 5/5?
You
What
can
am I
take
Yes, it's 1 hole. Good job, Bella. It's just 1 hole. And it's funny, if you guys look at this and you think about it, I have a group of fifths, or a fifth, 5 times. It's going to be a hole. Just like if I had 1/6 times 6, it'd be 6/6. So anytime you see this unit fraction times itself like that, you will notice it ends up being a whole. Good job, Bella. Let's do now, I want to move on now to doing some actual, let's do 24 instead. So this time I want to multiply 2 fractions together. So I'll give you guys a quick second to do it in your notebook. And then I'd love to hear from somebody else that we haven't heard from yet. So give you a second. When you're done, will you just shout out, "I'm done"? Don't shout out the answer, but just let me know you're ready.
I'm done.
Thanks, Aaliyah.
I'm done.
I'm done.
Wow, you guys are getting quick.
I'm done.
Oh my goodness. Wow. That was the fastest problem ever. Who could volunteer to solve this that hasn't shared yet?
Me.
All right, Miss Aaliyah. Love to hear from you. What would you do first, Aaliyah?
So first I times 7 times 1, which will give me 7.
Yes, ma'am.
And next I'll do 8 times 3, which will give me 24.
Wow, and why do you know that works?
Because they just go good together, and when I do my fingers, I count by 3, 8 times, I get 24.
And if you wanted, you guys, if you're still hanging on to the area model or the fraction bars, this is another one you could do the same thing with, right? So you split it into thirds. It's going to be hard on my screen because this is going to be really small. We're only working with 1/3, right? Because we're 7/8 of 1/3. So I'm going to color this in really quick. So I'm only working with 1/3. And then you need to find 7/8 of that. So then I would take I'm going to use a blue now. I need to split this into eighths. So I would have half, fourths, and then eighths. Obviously, if you guys are doing this in your notebook, yours would look a whole lot better. That wasn't actually too bad. And then I know if I split all of these into eighths, I would have a total of 24 pieces. I'm not going to do the whole thing because it takes too long, but I would have 24 pieces because I split my thirds into eighths, and I'm using 7 of those 24 pieces. Aaliyah, can I simplify this any smaller?
I don't really know.
Well, let's ask you this. Does 7 go into 24? 7, 14, what's next?
21.
21, and then 28. So 7 doesn't go into 24. A lot of times, if they're divisible by 2, if you have even numbers, you can definitely make it smaller. But 7's a prime number. So generally, when you're working, unless it was 7, 20, how would you say that? 21sts? 21s? Then it would work. But right here, Aaliyah, you're done. You're stuck. It's over. Beautiful job. Let's do one more together. Let's make it a really hard one. You guys ready for that? I think you are. I'm going to scroll down. Here we go. All right. We're going to do some bigger ones now. Let's do number 6. So 2 16ths times 4 21sts. Go ahead and set it up. This one might take a little longer because you're multiplying a 2-digit number on the bottom. So you're going to do the same thing here. You'll do 2 times 4 across the top, but then on the bottom, 16 times 21. You could
I
set up,
have the answer.
okay. You could set up your area model, or you could set up a standard algorithm. If you're done with 6, please go ahead and do 2. But if you're still working, then just stick with 6, okay?
I have the answer for number 2 as well now.
Alrighty.
Two. Yep.
Do you boys want to try
It's
13?
quite easy.
You can try 13 also if you want. Ridian, I'm gonna borrow you to do number 6 in just a second, okay? I want to give everyone about 20 more seconds. And so I think you guys, what you'll start to notice is this push with this is our denominators are getting bigger. So we have to use a little bit bigger multiplication problems on the bottom. And then our simplifying, because our fractions get so big with these big denominators, we want to simplify them to make them smaller. So Ridian, can you walk us through number 6 real quick?
Okay. Wait. Which one? I accidentally did a different one.
Oh, that's okay. Do you want us to come back to you for a different one then?
Yeah, I did. It was the one with like 8, 7, 49, and 10.
8, 7, 49, and 10. I don't know which one you're looking at.
It was 8 49ths times 7 tenths.
11.
Oh, that's okay. So why don't you try to solve number 6 now? Justin, will
I
you?
did number 2 though.
Oh, you did number 11. I see. Justin, will you walk us through number 6 then?
Sure.
Okay.
So we know that 2 times 4 is 8. So we can have
Yes.
that as our numerator
Mm-hmm.
for now. And then we need to do 16 times 21.
Do you prefer, Justin, to do it like the standard algorithm like this on top of each other?
I like to do it stacked. It gets me a lot simpler.
Perfect. Can you walk us through this?
So basically what I do is the turtleneck method
Mm-hmm.
whenever we are multiplying 2 digits times 2 digits.
Okay.
So 1 times 6 is 6.
Mm-hmm.
So we can have that. And then 1 times 1 is 1.
Yep.
And then we switch over and
Mm-hmm.
then we do 2 times 6,
Mm-hmm.
which is 12.
Mm-hmm.
So then we carry over the 1.
Yep.
And then now it's 2 times 2. Or 2 times 1 plus 1.
Yes, there you go.
And that would be 4.
Well,
Three.
2 times 3. There you go. Okay.
So then we add 16 plus 320.
Mm-hmm.
So 6 plus 0 is 6. 1 plus 2 is 2, and 0 plus 3 is 3. So we have 336
Whoa.
denominator.
Yikes. What do you think about this? Do you like that? Do you think you
I
would
feel
be
like
better if
I
I
feel
could
like-
make it smaller?
Yeah, I think we could simplify it a lot more.
And this is where you guys, you'll notice on 3-5 is they start giving you these fractions where your denominator is just so huge. And this is also where you'll notice like our area model and our fraction bars don't really work anymore. There's no way on your fraction bars you can have 336ths. You would have so many pieces on that fraction bar. It'd take you all day to draw it. Justin, should we try dividing it by 2? Should we try dividing it by 4? What do you think?
I think
Or
I
8
think
even?
we
What do you
should divide it by 4.
Let's try 4 to start with, because that'll make it simpler.
'Cause- Yeah, I know 80 goes into 336,
Mm-hmm.
I think.
Mm-hmm.
So we can do that by 4. So 80 divided by 336.
And the good thing too is if you look at this, 36, 4 goes into it typically, right? Without the 300. So that's usually a good starting point. If you look at this and you're like, I know 4 goes into 36, then probably a good way to divide, right? So 8 divided by 4 is 2. You guys in your notebook, see, this is where this gets a little trickier, is all of a sudden our fractions turn into multiplication and long division. So we got to make sure, that's why I'm having us practice our multiplication facts too. So if you haven't done it yet, then 336 divided by 4 in your notebook. Oh, my mouse is running out of batteries. There we go. All right, Justin, I'm gonna keep you hanging on here. Can you walk us through long division? What do you think?
So
Or do you want-
336 divided by 4.
Mm-hmm.
Hmm.
Do you want me to go through it? Because I know you guys haven't done long division in a long time.
Yeah.
Okay. So I would look at this, and I want everyone paying attention because we're actually long division. It's been a long time since you've done long division. And once these denominators get bigger, you're going to have to start doing it again. So 4 cannot go into 3. So then I'm going to make it into a 33. Can 4 go into 33?
Yes.
Yes.
But it's
I
not
have the
even.
answer.
It's
Okay,
not
what's that?
exactly even, but it can go into 43.
How many times?
33.
8.
So
Yep.
Yeah.
Mm-hmm. So now 8 times 4 is
32.
Times 4 is 32.
2. Now I need to subtract.
33 minus 32 is 1.
Mm-hmm.
1.
And then we drop down the 6 to there. 16.
2.
So at that
Where's
point,
that
we
going?
have 2/16.
2/16?
Yeah.
How many times does 4 go into 16? 4 times.
4.
Yep, there you go. And we have no remainder, no nothing. So now I have 2/84ths, and I could simplify it one more time if I really wanted to get crazy. And it would be 1/42. So you guys see, the tricky part about this is just the fact that simplifying some of these, not all of them, some of them simplify really, really quick. Some of them take forever to simplify. And so I think our hang up, I've noticed with our work, it's not so much the multiplication of the fractions, it's the simplifying. We've gotten really good at the multiplication part, but then the tricky part comes in when we have to simplify these really, really huge numbers. Because then it turns into what I'd like to call educated guessing. You have to look at 8/336 and be like, Okay, what might go into both of them? And so that's what they call this. There's a lot of guess and check with long division here. You're kind of thinking to yourself, okay, what fact do I think goes into it? Probably 4, maybe 8. So that's where you kind of have to go test it. So I will tell you guys, these problems just take a lot longer. That's why I've kind of cut back the number of problems you have to complete, because each problem itself takes a couple of minutes. So no need to rush through it. Let's do one more together. And then I'm gonna let you go. I wanna do a word problem together though. So hopefully you're taking your notes. Let's do number 14. Let's do 14 and then I'll let you guys go, okay? So in the Fireside Ski Shop, 11/28 of the ski caps have blue tassels. Of the caps with tassels, 7/11 are, or excuse me, I read ahead. 11/28 of the ski caps have tassels. Of the ski caps with tassels, 7/11 are blue. What fraction of the caps in the shop are blue with tassels? So who could tell me, and Quinn, I heard you speaking up earlier, what would our equation be? Quinn, do you want to help us out? You were doing a good job earlier.
Sure.
Okay, so what would our equation be here? What are we multiplying?
11/28 and 7/11.
All right, so I'm gonna give you guys a quick second. Set this up in your notebook. See if you can do it on your own. And then we'll chat, okay? So I'll give you a quick second.
I think I got the answer already.
Okay.
Well, the non-simplified answer.
Okay. Yeah, and even if you can get close, if you guys can get it without simplifying, I'm happy with that, but let's push ourselves to try to get to that simplifying. And again, that just comes with time, right? One of those things we will just keep working on. So could someone give me the multiplication of fractions? You don't have to simplify it. Who can just multiply across for me?
I got the answer.
Got it.
Yes.
Oh my God.
Asher, love to hear from you.
I
Okay.
think it's 77.
Yes.
200.
Okay. So 77. And then what'd you do on the bottom? I'll put it over here.
208.
Can you walk us through your multiplication real quick?
I knew
Can you,
that.
can you see my drawing over here?
Yeah.
Okay.
I
So
knew
what do I need to
that.
do first?
What I did was 2 times 10, and then.
Oh, do you want
next
to split it
one,
apart into partial products instead?
And then. I know I got 390, so I know this can mess up.
Why don't we do, Asher, can I walk you through this way real quick?
Yeah.
Does that work? Okay, so let's start in our ones. What's 1 times 8?
8,
Yes, sir. And now 1 times 2 is?
2,
Luckily, multiplying by 11s is pretty nice, huh? Drop down by 0. 1 times 8 again.
is 8,
Yeah. And then 2 times 1 again is?
2.
Wow, those 11s facts are nice, aren't they? So like you said, Asher, you already said this answer earlier, but 208 is right. But how many of you look at this, and if someone asked you, let's say you own the ski shop, and you're asking your employee, you're like, hey, employee, figure out how many of our ski caps have blue tassels. And your employee comes back to you and he's like, boss, 77 208 hats have tassels. How many of you would be like, what in the world are you talking about? That is not a friendly fraction whatsoever. Asher, any ideas for how we could make this smaller? Any thought?
You have to divide.
What could we divide by, though? I notice if I look at both of these fractions, I notice a common number. Does anyone else notice? Both fractions are multiples.
7.
Uh,
7.
well, look at your fractions here. I have 11 28ths and 7 11ths. So both of my numbers end up being multiples of 11, right?
Oh.
Yeah, because 11 times 7 on the top, 28 times 11 on the bottom. They're both multiples of 11, so I can actually divide both of them by 11. And you're going to laugh when you end up with this number. Watch. So we decided that, and hopefully in our head, can you guys all do 77 divided by 11 in your head, I hope? Because it's just doubles.
Just
Just 7. Yeah. Okay. Now, if we look at what Asher did over here, it looks like 208 divided by 11 would give us
7/28.
28. Dun, dun, dun. 7/28. Anyone go further?
No.
No? Anyone?
Because
Anyone?
7 goes in, you can simplify it.
What can you do, Justin?
Well, 7 goes into 28 exactly. 7, 14, 21, 28.
Aha! 20, yes, 28 is a multiple of 7. So I know 7 divided by 7 is 1. And Justin, what's 28 divided by 7?
28 divided by 7 is 4.
So here's what I think is so, I don't know if I would say it's funny, but it is kind of funny to me, is that we started out with the most outrageous fraction I've ever seen. 77 208. And like we said, he's like, hey boss, 77 208 of our hats have blue tassels. You'd have absolutely no idea what he's talking about. We've simplified it all the way down to saying, hey boss, 1/4 of our caps have blue tassels. Oh, wow. Way easier to handle, right? So this process here of simplifying is so important because I think, I mean, honestly, it gets you down to usually unit fractions, which is important. But in your real life type situation, it's really important that if you're using measurements or you're using calculations, like as an adult, you want it to be as simple as possible, right? I would never tell someone in a cookie recipe that you need 77 208 cup of flour. That would be ridiculous. So again, getting it down to these unit fractions just makes it so much more manageable. This makes it understandable. It makes it easier for people to work with. So really the big push right now is being able to divide these fractions down until they can't get any smaller. Again, if they're prime, that's usually as small as they can go. Your goal would be pretty much to get it down to a unit fraction with a 1 on top, but obviously that's not always possible. I hope we have this put in our notebook. I'm making you guys a very sweet deal